Why dual nature? You know the dual meaning? The dual mean the double. Here dual nature implies that the wave nature as well as the particle nature. You know very well, there are some experiments related to the EM radiations like interference, diffractions. The result of these experiments can be explained only if we consider that EM radiation having the wave nature. On the other hand, there are some experiments like photoelectric effect, Compton effect. The result of these effects, or you can say these effects, can be explained if we consider the EM radiations having the energy in the form of packets, that is quanta. That is, EM radiation possess particle properties. Here particle mean photons. The photon concepts, you know. The photon concepts successfully explains the Compton effect as well as the photoelectric effect. And photon, you know, photon mean that the energy is quantized, it is in the form of packets, that is called quanta or the photons. We are having some experiments which shows the wave nature of EM radiation. On the other hand, we are having experiments which shows particle nature of the EM radiation. That is, EM radiation having both the nature, wave nature as well as the particle nature, and this is called the dual nature. Now it is concluded that now EM radiation has a dual nature. It means that EM radiation behaves as wave in some processes like interference, diffraction, and behaves like particle in some other processes like photoelectric effect, Compton effect. And it never shows both nature at the same time. This is very important. EM radiation only shows one nature at a particular experiment. Now we are coming dual nature of matter. Now the scientist D. Berkeley has a feeling that the nature loves symmetry. Nature loves symmetry. That means if the wave having both the nature, wave as well as particle, so that means matter should possess both the nature. So material particle or the matter should possess the wave nature as well as particle nature. Now your material particles such as electrons, protons, they are particles, but they must have the wave nature according to de Broglie. Because wave having particle nature, so particle should have the wave nature. A material particle has the matter wave associated with it, and that matter wave is called de Broglie wave. And it is very important to understand Typically, or the matter wave is not like EM radiations. It is not like light, X-rays, gamma rays. Okay. They are the de Broglie or the matter wave. They are actually probability waves. So they are not electromagnetic. Very, very important. Now, first of all, for coming EM radiation, photons are associated with EM radiation. Energy of the photon is h nu. Because the photon having the mass h nu over c square, so E equals to mc square. Now equating both the equation, left hand side same. From here we find the mass of the photon. So mass of the photon, very, very important, h nu by c square. So photon having the momentum, because it is having the mass, and its velocity equals to the velocity of light. So momentum of the photon is mc, substituting m here. So momentum comes out equals to h nu by c, or we can say h upon lambda, or lambda is h over momentum. This is true for EM radiation. Now de Broglie suggests the same relation must be applicable for the matter also. So if m is the mass of the matter moving with velocity v, momentum mv, substituting p here, so lambda becomes h over mv. This is the relation for the matter waves. Important to understand, this relation is for matter wave, because v is the velocity with which the matter is moving, and there is no charge coming in the relation, so lambda is independent of charge. Matter wave, they are not related to any charge, and because lambda is inversely proportional to velocity, faster the electron or the proton or any matter is moving, smaller will be the wavelength. Lambda is inversely proportional to the mass. Heavier the mass, smaller will be the wavelength, lesser will be the wavelength. Lambda is h over mv, so if v equals to 0, substituting v0, lambda becomes infinite. Infinite lambda means no wave. That is, no wave is associated. No wave is existing if the matter is at rest. Now we are coming, what is the de Broglie wavelength associated with an electron? If it is accelerated in a potential, v, then what will be the wavelength associated with the electron? First of all, the lambda for the matter wave, h upon mv. P is momentum, mv. Kinetic energy of the electron is half mv square, dividing by m. So it becomes half p square upon m. Or p square becomes 2me. P is the root of 2me. Now if the electron, substituting p here, the lambda becomes, so this is the value of lambda. Now electron is accelerated in a potential difference v. So energy acquired by the electron is EV. V means potential, substituting the value of E here. Okay. So this becomes the relation. Now H is Planck's constant. M is the mass of the electron. E is charge of the electron. All are constants. Substituting the constant values, So mass, charge, Planck's constant. Unit are very important. Substituting all the values, relation becomes 12.3 upon under root v into 10 raised to the power minus 10 meter. Now you just see. Now according to this relation, lambda is equals to 12.3 upon under root of v angstrom. V is potential. And lambda is, coming. V is in the denominator. V potential is in the denominator and it is in the root. So for more potential, lesser will be the wavelength. Lesser will be the wavelength of the matter wave. If V is 100 volt, lambda becomes 1.23 angstrom. Very, very important. So this is a relation. Directly substituting the value of the potential, you will get the wavelength of the matter wave. Okay? Thank you very much.